Response video to holiday. Kinetic dynamics, mechanics, questions for an amendment. Alright, so we're still stuck on, I guess my argument would be here is that you're doing this forest tree thing, okay? There's this whole forest of an idea that unifies gravity and magnetism and the nuclear forces by understanding them as a see, I was going to say a wave, as being created by a pushing force. The universe has this stuff in it that's coming from all directions, and it's just basically pushing everything together because it's like a pressure wave or whatever you want to call it in an explosion. It's just this area of particulates that through just a massive density and a certain amount of time have interacted enough to create a chaos. So there's a chaos of this noise that is effectively pushing everything together. Alright, and so this is a unification theory and blah blah blah, and so that to me is the forest. Now, okay, these individual trees are what we're going to have to make it out of, and I just don't know if this minutia is at all constructive, especially in comparison to the current theories where, photons go surfing on invisible waves, and you're okay with that. You don't seem to hold that to the same scrutiny, I suppose. And even engage in conversations about entanglement and breaking the speed of light and all kinds of things that you would think you would need some kind of real demonstration of how that's practically feasible. But anyway, enough nitpicking about your nitpicking, but frankly, I just see it as that. So this kinetic model, I'm using the word kinetic because I'm just trying to break it down to a system that's understandable. And we can all understand that kinetics, in terms of this conservation idea, that two things go in, and the only thing that really changes is two things leave in different directions. And that's all that they really exchange is direction. Substantially. But obviously these photons, there's certain premises built in that are not very intuitively, we never see something that can't change its speed, so we don't really imagine something that has a constant speed easily. But yet that's just one of the rules. We kind of know that this light stuff always moves at this speed and you're not going to slow it down. But the idea that you would change its direction is perfectly intuitive. The idea that lensing is possible and all these other things, refraction is possible, that something goes into an atom and it leaves the atom in a different direction, and neither the atom or the thing has substantially changed. The only thing that's changed is this dynamic. I guess I would argue that Feynman's understanding of quantum electrodynamics does explain the mathematics and just explain the conservation of this interaction between photons and electrons, and that this interaction happens in the context of time, and that yes, what does happen in fact is the photon leaves at a certain direction, the interaction, the electron leaves at a changed direction, changed tendency, and that's what all that happened, is the two things are changed by the interaction, but nothing else changes about them. Their mass doesn't change, and their velocity doesn't change. Now for an electron it gets a little more complicated because velocity is a different kind of function. Their velocity, the electron is made out of parts, and the parts are what's getting changed. So they have a change in their potential. So the electron's potential is changed, where the photon's direction is changed. But what really exchanged was something more basic, which was some sort of photon on photon on photon encounter. Alright, so these are just rules, premises. You don't want to accept them, you don't have to accept them. I'm just saying that if you're going to argue the theory, you have to argue in the context of what is being claimed to be the rules. And this is just a rule. There is no change in momentum. And photons just don't care. It takes zero energy, zero, to change their direction. So if you think about it as being fish swimming, and the fish can only swim one speed, and the fish don't care which way they're swimming. It doesn't take extra wiggles or extra force to change their direction. They swim exactly the same amount. They just move a fin, let's say, or whatever, and let's just negate that takes any energy. That moving their fins does not require energy, so that they can go any direction, any time, and it takes no energy. Their tail's always moving, you could say, and all they're doing is changing the angle of the tail, and it takes no energy. I'm just saying there's no energy consumed in the interaction. And I'm just saying to these bodies that make up the universe, there's no energy required for them to change direction. All they need is the suggestion. They encounter something that rubs up against them, so to speak, kinetically, in a kinetic kind of way. Let's put it kinetic kind of way. And they leave in a different direction through the interaction. Alright. So, I don't know whether we need to... I could make the argument about gravity or some other kind of, example, I suppose, that maybe might work for you. I don't know. So if you just said that gravity was a conserved force too, that something could go into a gravitational field and leave the gravitational field in a new direction, and that nothing substantially changes. The body isn't heavier, the thing doesn't move faster, they just both exchange directional information in the end. It goes into the gravity well, it goes faster, then it goes slower, leaving, and nothing changes except direction. And that's the kind of mechanics that we're talking about. So I really, illustrating it, number one, I can't illustrate in 3 dimensions, so yeah, you have to do some kind of 2-dimensional model. And I can understand some of your objections, but I'm just saying for the sake of this argument, there will be a rule, about the kinetics. So, let's just do a little bit of drawing maybe. So something's going this way, and then you have these different other things that can encounter. It can encounter something coming head on, and I've sort of explained what I think would happen in that interaction, which would be nothing. One body would leave going this way, one body would leave going this way, and nothing would change. And then likewise with this directly horizontal interaction, you're still doing it in 3-dimensional space, which adds another component, in reality. So, that directional information would probably be the thing getting changed. So maybe there would be, one body would still leave in the same amount of x direction, and one body would leave in the same amount of y direction, but it would be the z direction on each one that would be new and changed. So that's where I'm just saying that's probably what might account for the lack of clarity in a 2-dimensional drawing. But whatever. Obviously each individual body only has direction in one direction. It's just going one way. It's not going 3 ways at once. It's not saying to itself, I will go a little bit in the x component and a little bit in the y component, a little bit. That's not happening. Where that might be happening in bigger bodies that are wobbling their way through space. But let's argue that these things don't do any wobbling. They just travel in a straight line from point A to point B. And if they interact with each other in a certain way, they don't get to point B, they end up at point C. Kind of thing. So they end up going, in a straight line to B, and then they bounce off of B's interaction and end up at C. It's just... So anyway, so obviously there'd be different kinds of dynamics for different angular interactions, and you could just argue that you could always just draw some sort of straight line through an interaction. So you could almost say if they came in at the same angle and interacted, that they might leave together, associated. Maybe that's a possibility. And, so there'd be just different combinations, and the fact is you just conserve. The rule is that it would be conserved. That would be the rule. So it's not like it can violate the rule. The rule is there has to be a conservation, because there's nothing that can be given away except direction. So unless you can account for how, and again I'll just argue that one of the premises of the argument is that the fish just couldn't care. It has no momentum that has to be overcome. So it doesn't have a mass that has to be stopped and then restarted, right? So in that sense, there's no kinetic friction. I mean, it's purely frictionless in that there's no friction to its movement in any one direction. There's just a friction, a rule against changing its speed. Okay, so yeah, I mean, figuring out all the mathematics of this is maybe would be an interesting exercise for me to get involved in doing some of that, maybe. But again, I'm just saying that that's already math done. That's already Feynman's quantum electrodynamics. It's not something I should have to redo. But I mean, if somebody insists I redo it, I'll redo it. So look, the understanding is you just have to understand the order of these particles also. Let's just go with the big ones. I mean, protons, neutrons, and electrons. My argument is these are already complex bodies with maybe 1,000,000 density of swirling, things moving in all kinds of directions in a knot and swirl of patterns built into them. It's a plasma of photons, all right, that are being compressed into those patterns by a constant barrage of pressure of those constituent pieces. So they're balls that have essentially, through this chaos interaction, that they've ended up, in some sort of together thing. And then this little nutsack here has, again, so it has a trajectory, and then another one hits it at the right angle, and it becomes a threesome, and then it becomes a foursome. And there's consequences to now its movement as soon as it has any thickness to it, because now it has to move, the individual parts have to move in a very particular way to all maintain their speed of light. Alright, so what else I got to say on that? Alright, I'll go to frequencies. I mean, I just, like I said, I just don't know how. I really don't need, I think, to get too deep into the kinetics. I'm just saying it's a rule that there's conservation. It's a rule that there's no obstacle to a change in direction. There's no momentum that has to be overcome. And so the bodies will gladly exchange directional information when they encounter each other. They don't have they have no resistance to the suggestion to go that way instead of that way. But there certainly are rules about what kind of interactions will result in directional information. And one of the rules is the head-on collisions will get you nowhere. That directly horizontal collisions may get you nowhere. Certain angular changes will result in no apparent angular change, no change that's obvious. I mean, yes, it's a different photon going one way and a different photon going the other way, but there wasn't really any exchange. So it's a different rules for kinetics. Yes, it's not Newtonian kinetics in the sense that these bodies don't have mass and they don't have variable velocity. I mean, Newtonian mechanics isn't really about things that don't have variable velocity. So I'm just saying it is one of these things you thought experiment, like the pool balls moving in the frictionless environment. It's sort of like that in the, in the sense, if you just make the rule that none of them can be changed in their speed. So if you just understand that they're all got a spin or they all have a certain mechanism that just makes it so it's impossible for them to stop, then you can just understand that the motion doesn't really, that the energy in the system is the same energy, and the only thing that can really happen is they get stuck in patterns. I don't know why that. I'm just saying that this should be a relatively easy point to concede as a premise, and then just move on to the bigger stuff. I'm just saying all this little minutia stuff is all mathematics and nice, and that's all great, but I just don't know if it's critical to the vision thing regarding the general theory. Maybe you do. I mean, like I said, I just don't know if any of the theories of the last 100 years have been obligated to be that dense or that granular. I don't see any granularity to all these other interpretations. I don't see any granularity whatsoever to even the theory that photons carry, um, you know, a component of magnetism and a component of electricity that really has anything to do with electromagnetic anything. Do they have any wave component at all? But anyway, alright, so the other thing was the frequency thing, and the frequency one I think is really important. So, and why there's a difference. So I would argue that you could imagine that these little bits, once they get associated with each other, that, alright, the first thing I'd say is the association is just a, let's see, I mean, we understand there's magnetism and polarization, and that those things are effects caused by association, in this gravity thing. But underneath the gravity, at the mechanism of the gravity, the thing that actually causes that effect, certainly the photons I'm arguing are in association with each other by no will of their own, except there may be this possibility that photons do have a shape, and that shape is conducive to them fitting into each other, and that once they fit into each other, that might be what they end up being in the form of matter. Like they could be condensed into matter because there is no lost space. They're compacted. Okay, that's why the density of these particles is so high. The energy in them is so high. These tiny little nuclear particles seem to have an awful lot of photons in them per their size. So I'm just saying that would lend one to believe that they are closely associated, and that association might be in some form where it just makes it easier to change the shape of this snake with a single interaction. So now a single graviton could hit this snake and move the entire snake's direction, because they would follow each other. So you wouldn't need an individual kinetic impact on each individual element of the photons to create a change in its direction. So if you think in those terms, that the snake would have a head, and if you change the head, you change where the rest of the body goes. So I would argue that kind of a mechanism is likely part of this construction of matter from this chaos of tiny energetic particles moving the speed of light. So everything's made out of just these little particles moving the speed of light. Everything is made of them. The gravity and the matter, and everything is made of those. And the difference between the matter and the gravity is the fact that the matter gets caught in these kinds of associations. Now, light, the photons we recognize, the gravity we can see. So let's call all the photons. See, this is the problem I'm going to run into, right? I mean, either we call gravity, we make gravity part of the electromagnetic spectrum and just call it another photon, like a cosmic ray that we just can't see, or we call the electromagnetic spectrum gravitons in packets, so are quanta in packets. So that's the obligation. It's one or the other, but yeah, I don't know what the naming convention should be. Just we're stuck with an archaic perception, and now we have to change this archaic perception into the accurate description, and now the language sort of fails. Alright, so anyway, but yeah, so photons of light are not tied to each other by anything other than the circumstance of their birth. They're created in association with each other. Okay, the electron admits them in association with each other from an identical vector, an identical, whatever the mechanism is. It's a spinning wheel, and it releases, at a certain point in its, and let's say it's wobbling and back and forth in this direction, and as it wobbles back and forth in this direction in a certain state of overstuffing, it's a little too full. The snake is longer than it should be, and its tail has surpassed its head, and so it will release extra weight, so to speak, And the simple explanation could be that it only releases that extra weight at a certain point in its vibration. So the first photon's released at the first orbit, and then it goes around, and it will release another one at exactly that same point. And so they will end up leaving at the frequency of that cycle of spin. And they will do it for as long as they do it, and there'll be a packet of photons that leave on this vector in a row at exactly the same period. And we'll call that a packet of light. But those photons have no connection to each other besides the fact that they were created in a pattern. And so they can be broken into gravity per se, probably without any obligation, without a problem. You can have you could absorb say 3 of them and convert that into infrared and lose one of them as a graviton. May be possible. I would just say that the loss of the graviton will still allow for this exchange of pure directional information. So, and again, I guess that just has to be looked at as again, it's not that hard to understand that if there's this plasma of stuff that's wobbling its way through a path, okay, so the stuff is swirling, it's moving kind of funky, but everything in it now is moving exactly the speed of light because of all these twisting motions. It accounts for all the different nuances of all the pieces. The snakes are all lined up in the proper snaking pattern to mean that everything moves the speed of light. And then a single object flies into that at a certain angle. It seems logical, reasonable to speculate that the thing may leave at a different direction, and whatever this change is, this angular change, it will be imposed on this thing. So it will now subtly be changed in its pattern. The pattern will absorb a change in direction. And that's what I mean by an exchange of directional information, that exactly the same rules are obeyed, everything's moving the speed of light, and all that's happened is something was moving this way in three-dimensional space. It now goes away this way, and the difference, which would be that way, is what the other thing has given to the exchange. So, but I don't know the exact. I mean, again, I can spend some weeks going through different models and trying to get some, maybe with graph paper and doing all this stuff to figure out exactly what the kinetics would be. But I just don't know if that's the best use of my time to explain what I think is a depth of granularity that really isn't necessary, in the sense that we already have it built into quantum mechanics. We already have evidence that there's an interaction between photons and electrons where the only thing exchanged is directional information. All right. So frequency would have, it's just incidental. And the thing you have to understand is the reason why everything else isn't just by accident coming at exactly the same vector is because of the depth, the depth of the grain, the granularity of the universe itself. The universe has it's so dense, it's so that even a subtle difference, in 2 packets or 2 alignments isn't the same. It's not going to meet at the right time. It's not going to hit the same place on the atom at the same time, sufficiently close enough, let's say, for something to be perceived. So if you think of the electron as having a pretty small size, and then the fact would be is that you have to have 2 photons come at it that are so much in the alignment that they'll be able to both hit within some required width or diameter of a photon. That they can't be more than a photon in diameter off in their vectoring to be able to create the response that will be created in the atom, because it got hit twice. Okay, it absorbed 2 pieces of momentum before it could go through a cycle of its atomic structure. And so with those 2 impacts in one direction, it is now altered enough in its circumstance, this is the tipping argument, you know, it tips the electron. It tips it into a configuration from which it can't recover without disposing of some photons. How else to explain that? So certainly gravity could accidentally create something that looks like a photon, I suppose, you know, just randomly, but it's not enough for us to identify anyway. But I'm sure it happens. It happens with a lot of this equipment we have. You know, this highly sensitive equipment often has what's called background noise, where we call them false positives, but they're not really false positives. They're just the fact that, yeah, there probably is stuff that comes in and mimics a photon, you know, or something like that, is close enough by accident. Yeah. So what else? But I can't really establish those rules because, again, that's a granularity where I haven't gone through all the implications of every single circumstance and say, yes, that's realistically possible. I'm just saying from observation we sort of know certain rules exist, that whatever interaction is happening between these quanta, the quanta don't react naturally. That they need this barometric matter thing. That they need this. They need quanta stuck in a snake. You know, to do this kinetic thing with it. That they can't react with it kinetically unless it's, you know, got this slight locked mechanism. Because when they do it in the regular field, it doesn't seem like anything is happening out there. I mean, there's no evidence that we can bang photons off of each other and change the direction of light or break it into smaller quanta. Clearly we can if we put it through matter. Then we can change it into all kinds of different kinds of photons. You know, so you know that's sort of an indication that that it's, once it's trapped in these plasmas, that maybe it's you know, like I tend to try to indicate that maybe the only reactions happen when there's 3 quanta or 4 quanta involved in the interaction, and maybe that's the only circumstance in which direction is exchanged. I don't know the rules. I'm just saying we sort of already know those rules exist, and I'm just saying I think it's quite plausible that we can come up with a mechanics obeying the rule. Yeah, that there's no change in speed, and there's no change in size, and the only thing exchanged in the interaction is direction, movement, orientation, vector orientation. I mean, I just don't think that's implausible. I don't think it. But I just, like I said, I just don't know if I want to immerse myself in that when there's, I think, going to be more interesting questions to answer on the general subject of the applicability to magnetism and electricity, and I think understanding the whole nuclear thing in the sense that the proton and the neutron, as I explained, are creating both a net pull and push, so that as they spin around each other like magnets, you know, any one moment they're pushing the electron away or ending up pushing it towards them, in the sense that the electron ends up feeling less pressure or more pressure depending on which one's filtering it. You know, so if the neutron and the proton are lined up with each other, they're going to feel the effect of the proton. If they're lined up this way, then they're going to feel the effect of the neutron. So throughout their orbit, they're being obliged to maintain this orbit, not because of just the external pressure, but because they're getting a filtered and a changing orientation from the nucleus itself. It's like having a polarized sun, you know, a truly polarized one that was north on one side and south on the other side, and it spun. You could imagine that would have a tremendous impact on the Earth's orbit, in the sense that it might not, the dynamics that keep the Earth in its orbit would be different, because it wouldn't be so much about how fast the Earth was going anymore. it would be about the distance of the orbit. And that might be, I think it's a plausible explanation for why the orbits around atoms are fixed, generally speaking, is because of that magnetic force, which is still gravity. It's just filtered gravity. Yeah, so I mean, this is probably enough. I mean, like I said, I don't know if I want to waste, use my time to go through all these kinetic variables. I'm just saying that I think we do know that these are not outlandish premises, that the quanta move the speed of light and don't do anything else ever, that you could imagine if you create a whole universe and you just randomly threw these quanta into it. Holy shit, that reminds me when I was a kid. I used to dream about this when I was 5 years old. I didn't really realize that till just now. I talked about it in a couple of videos, that when I was a kid at night I would see little tiny, like little pixels, little round spheres, and they would swirl in all kinds of different colors and patterns every time the lights were turned off. I mean, I'd have my eyes wide open and they'd fill the room. And I just say, gee, that is so spooky when I think about it. I mean, it doesn't make me believe in God, don't get me wrong, but it is just spooky that this is matching that. I mean, when I just talked about the whole universe and the idea that you can imagine that if you have these little things and they're all moving, a constant speed, and that and if you threw them in there in some sort of regular pattern, that they would end up, in some irregular pattern in no time at all. So anyway, enough of a video for this term, I think. So I'll be back. And like I said, I'm not saying your objections are wrong. I'm just saying I just don't know whether they really need the kind of depth of explanation beyond saying, well, look, these are the rules. Okay, they move the speed of light. They don't care. It requires no energy to initiate them in any direction. They don't care which direction they're going. And so any suggestion through communication with another body, they're more than willing. But there is a rule. I mean, they can't just both come in and say, let's both go this, we'll crash this way head on and then we'll both go that way. They're not going to do that. But there are rules, not too complicated, and we sort of already know that there's existing rules. Just because light doesn't interact with light and all these other things don't seem to interact with itself very much, so there are rules about how these interactions take place, where this suggestion that I will impart directional information and we will exchange directional information takes place. I don't think that's an unacceptable statement as a premise. It's not like saying there is a God. It's not that outrageous. It's quite imaginable, I would say, and it's quite imaginable that you could build such a stadium, a game. It's not like I'm suggesting a game that's like, okay, you have a field and you have 700-foot gladiators with, swords that are machine guns, and, I mean, it's not some preposterous thing. It's a quite reasonable statement of the general dynamics. It doesn't take that much imagination to say, yeah, that's plausible.